Good morning, everyone, and welcome to our 5th Annual Chemical Engineering Graduate Symposium. My name is Corinne Jackman. I'm a third-year Chemical Engineering PhD student here at the University of Michigan, and I'm in the Lynn Lab. So today's event showcases the research that graduate students have done, mostly second through fourth years, but we do have some fifth years and maybe first years as well. The way that this program is divided is that we have 2 morning oral presentations, and then we have 2 afternoon oral presentations. And they are, in between, they are broken by small breaks, short 10-minute breaks intermittently. And after this, we will have a poster presentation, which is followed by awards and also a closing ceremony. So awards will be given out for best posters and both best oral presentations, and also for a research, teaching, and service award. Also with us, we have 5 different companies who have registered and who are here with us. We have 3 different sponsors. We have our gold sponsor, who is the Dow Chemical Company, and we have 2 bronze sponsors, P&G or Procter & Gamble, and Shell. We also have Dow Corning and Owens Chemical. So because we are here and as more students start to come in for this event, I encourage all of you to network and to mingle and to meet each other so that we can build relationships that'll last farther than in this room. So today joining us, we have our keynote speaker. Her name is Dean Rosemarie Wesson. And just before I call her up, I'm just going to, we actually have her bio on the 8th page of your program, but I'm going to give a few highlights about her. So our keynote speaker, Dr. Rosemarie D. Wesson, recently joined the Grove School of Engineering at City College of New York as the Associate Dean for Research. Dr. Wesson has over 13 years of experience at the National Science Foundation in the Directorate for Engineering and excelled as both a director and program director in the foundation. As acting director of the Emerging Frontiers in Research and Innovation Office, Dr. Wesson was a member of the engineering leadership team and led EFRI office. As a program director at NSF, she managed both small business and academic research portfolios focused on energy, nanotechnology, emerging research opportunities, and the field of chemical and biological separations. Dr. Wesson also has faculty experience. She was a member in the Department of Chemical Engineering at Louisiana State University in Baton Rouge, Louisiana, where she authored and co-authored in numerous technical papers, which include numerical analysis of polymer crystalline kinetics, structure property relationships of crystalline materials, and finite element analysis of polymeric flows. She also has experience in industry. Dr. Wesson worked as a senior research leader in the Corporate Material Science Research and Development Lab of Dow Chemical Company. Dr. Wesson's responsibilities included supervision and leadership in the polymer rheology research arena. Also, Dr. Wesson has also led nonprofit research. As a principal researcher at the Battelle Memorial Institute, she led a team to research and manufacture the Odyssey Atmosphere, which received an R&D 100 award for one of the 100 most technologically significant new products of the year. So as far as service, Dr. Wesson is an invited contributing author for the American Society of Engineering Education, Prism Magazine, and a fellow in the American Institute of Chemical Engineers, or ACHE. She has held numerous leadership positions within ACHE. She recently ended a 3-year term in the ACHE Board of Directors and received the 2014 Minority Action Committee Eminent Chemical Engineers Award for outstanding contributions to the minority chemical engineering community. She is also a member of the American Chemical Society and the American Society of Engineering Education. As far as education, Dr. Wesson has received her Bachelor of Science in Chemical Engineering from the Massachusetts Institute of Technology and her Master's and PhD, both in Chemical Engineering from the University of Michigan. Dr. Wesson is also a registered professional engineer. So we are very excited to hear from Dr. Wesson today and hear from her personal experiences. Please join me in welcoming Dr. Wesson.
Thank you. Thank you. So I am on, right? So now that you've heard all that about me, I thought I'd try to do something here a little bit different. As I was telling Corrine, and thank you for inviting me, I'm glad to be here, that I was thinking about how to structure this presentation. And then I said, well, we've got a lot of new people here, a lot of young people. And I was actually here, as Corrine said, in the 80s. So I was here at Michigan from 84 to 88 in the PhD program. So my question then became, how much do you guys know about Michigan from 84 to 88? So you're all students, right? Mostly students. So everybody comes with pencil and paper, correct? So let's pull out our pencils and paper. At least we have programs that we can write on. And if you don't have a pen or a pencil for this quiz that we're going to take, you can do it in your head. So that's how we're going to start out. We're going to refresh our memories about what was life like here in the 80s here in Michigan. And if you're a faculty member who has seen some of this presentation before, don't give out any answers. So, first question in our quiz. Seriously, who was the department chair? I came in 84, so I experienced 2 different department chairs. Does anybody know, now just think about it. Think about who were the past chairs in chemical engineering. And 30 years ago, more than 30 years ago, right? Who was the chair in chemical engineering? Everybody have an answer? Anybody want to guess? Yes, sir? Nope. Anybody else want to guess? Yes, sir? Close. Yes, ma'am? Was he ever chair? Oh, must have been before my time. Galari? Nope. I think it's time for an answer. Anybody know who that is? Heard of Schultz? He was the first chair when I got here. He was chair of chemical engineering. All right, so if you got that right, which no one did, you get 5 points. You keep track of your points. Who's the 10th chair? Came chair in 85 after Schultz. That was Fogler. He was chair from 85 to 90. So he was the 2nd chair. All right, so those were the easy questions. Who's the dean? Who's the dean now? All right, okay, who was the dean before him? Who was the dean before him? Anybody know who that is? Nobody knows who that is? Thank you. You don't get the points, but he was the dean when I got here. But as I said, I had 2 deans, I had 2 chairs, I had 2 deans. Who was the other one? Who was dean after Duderstadt? Well-known Michigan professor. Where was he? Was he in mechanical engineering? I think he was mechanical or either electrical engineering. Hey, you're going really far back. No. He left Michigan and he went to MIT. Became president of MIT. Come on. He left MIT and became president of the National Academy of Engineering. He taught me optics, so I think it was electrical engineering. Still, nobody has it? Ever seen this guy before? Can't call his name? Chuck Vest. He was a prominent Michigan person and went on to do great things. Still, I think we got zeros in the room, right? Zeros. No history here. This is even tougher. You still have Katz lectures? Every year you have a Katz lecture, right? All right, let me tell you the Katz lectures when I was here. Can you name any of these people?
Ted Davis.
Ted, oh, you yeah, you. I'm sorry, that's the only picture I can find, but that's a good one. Yes.
Alex Bell.
Anybody else? Thank you. Oh, you cheated. And then that was Scriven, Wang from MIT, and then we got Ted Davis. Those were our Katz lecturers back in the 80s. I think we still are at zero here. All right? How about faculty members in the department that were there in the 80s when I was there, 84 to 88? I'll tell you that there were 22 different faculty members. Now, not that all of them were there at the same time. Some came, some left, but there were 22 different people. All right, let's see what we got. I don't actually think I knew him. I think he left. I just don't remember him. Ed Young, Brymer Williams. Somebody said Brymer Williams. Do any of these faces look familiar to any of you guys? None whatsoever. Tech, Resin Tech? No, no? How about Cornahan? That's what Cornahan, I don't think he looked like that when I came. He probably looked like that in 1960. But and then there's Jim. Everybody has a soft spot for Jim. All right, can you name these people before I put the name? Because some of these people are still, you should know. That's Dale Briggs. Cadillac. Rain Curl. You guys didn't remember Jerry Schultz. Donahue. Now these next ones, that's my woman, Stacy. We like Stacy. Costas Cravars, and then Tassos Papnastasio. Now these are all that I named former. Now the next slide says current. Some of them are actually former because I think they've left by now. We couldn't find an older picture of Galari. He must have wiped the web. Wang, Henry Wang, yeah. Schwank. He's got hair. Ziff. Savage. And there's a young Levi. I think you guys are still pretty much at zero. First African American female to get a doctorate degree in chemical engineering from the University of Michigan. Any guesses? All right, so you got a few points on that one. I won't give you 100. I won't give you 100.
You said 100 points for that.
Everybody was like, you? All right, one more thing. Now, this is going to be easier. Yeah, right. This is what you know, right? Everybody knows Bo, right? You don't know Fogler, but you know Bo. Who preceded Bo? Preceded Bo. So Bo was back, what, 1969, so this was, yeah, I didn't know that. I mean, I don't know football. Yes? Elliot.
Wow. That's only 5 points for that? Like 250.
Who coached after Bo?
Gary Moore.
All right, how about basketball? Oh, sorry, who was the athlete of the year in '87? Football player.
Jim Harbaugh.
See, I tell you, people know their football, don't they? They don't know faculty in chemical engineering, but they know their football. basketball coach when I was here. Who's basketball coach? No, you know too much.
Was it Johnny Orr?
No, I don't even know who that is. 84 to 88 when I was here. When I put this up, it might cause a little bit of because he left kind of, yeah. Right. You want to tell us?
Yeah, go for it.
And last question. When I was here, we won the Big Ten championship in basketball. That's what they tell me. But in '86. And who led the team? Yeah, Ron Topley. Ron or Roy? It's Roy. Sorry, say I don't know how to. I just took it off the web. All right, so what do we got here? Who won?
Andy,
So this was now what I was really looking for were pictures of the campus back in the 80s, because things have changed so drastically that I get lost when I come to campus. These buildings that are here now, were not here, don't have them. You have to invite me back. I'll have to find pictures of the campus. But things have changed immensely. You don't have your one female faculty member anymore that everyone, the females in the graduate program, were just amazed by. There are a lot more females in the graduate program than there were when I was here in the 80s. There are a lot more underrepresented minorities in the graduate program than when I was here in the 80s. However, let me just acknowledge where I got all that stuff from. Jim Wilkes did the 100 years of chemical engineering, and so I stole a lot of pictures from there. But it's interesting to go back and look at how things were back in the 80s. And I'm just going to quickly say a few things and then allow you to ask me some questions if you want. But things have improved in chemical engineering. I can look out here and I can see how things have improved in chemical engineering. But in general, in engineering, things aren't much different from what they were in the 80s. This is data from NSF, and one of these buttons is a pointer. So the bottom line here, all engineers, and this is women in science and engineering occupations. So a little bit less than 10% in the 90s, a little bit more than 10% in 2010, but it's pretty flat. It's pretty flat. It's kind of depressing. If you look at bio, which is the black line, growth in bio, that's impressive. And if we could separate chemical engineering, I'd bet we'd see some, not similar growth, but we'd see growth in chemical engineering. But overall in engineering, NSF has thrown millions, billions of dollars at this issue. And overall in science and engineering, we don't see a lot of change. What do we do about it? My observations is that change is happening, but it is slow. And in terms of faculty, we see a lot of change in terms of junior faculty. There are a lot of women that are being hired as assistant professors, a lot of more underrepresented minorities than in the 80s are hired as assistant professors. But progression into the ranks, that's what we're struggling with. How do we do that? NSF has a program called Advance that tries to look at this issue, but what can we learn from the differences? How do we make changes so that we do have this growth in engineering that we want to see in biology? We want to see the same thing in engineering. How do we do that? There are programs across the country that have been successful, but they are isolated incidences. And we are trying to figure out how can we model those, how can we translate those, how can we make it more accessible to other people across the country. How do we change the culture? How do we make sure that what's happening across the country is positive? How can we make faster progress? There are lots of books and things out there, and I'm sure you've heard all about the lean in stuff, about the Google woman, positives and negatives, but I just take a little bit about that and say that the same thing in industry is occurring in terms of what we see in academics. It's the same in the industry, and I'm trying to get out of here. So some of the quotes that I like that are applicable, and then there's another book out there called Why Are We Concentrating on Fixing the Women? We Should Talk About Fixing the Managers, or everybody needs to have some kind of awareness to the situation. So the things that I try to say to people, and the things that I try to say to young people in general, is that when we talk about ideas to help grow and make everything equal for everyone, we're talking to everyone. It's not just that we're fixing one set and we're not talking to another set. So the fact that this room is probably about maybe 20% women, the conversation is to everyone. You know, the things that are being said are to be heard because you either have a spouse, you have a significant other, you more than likely have someone interested in science and engineering, or the men in the room are also working with the women that are in science and engineering. So some of the quotes from Lean In that I thought were applicable to everyone, and just advice in general. As you go out into the world, as you become professors, as you work in industry, as you work maybe in government, nonprofits, wherever you end up. One of the things that Cheryl was saying was, some of the things you do, some of the things you don't do are related to what happens if I fail. I'm not sure that if I try to go down this route, I'll be successful. So she said, what would you do if you weren't afraid? And then go ahead and do it. And then try it. Try some of those tough things that are out there to potentially do. Done is better than perfect, and I find myself doing this too. Lots of times you have a task to do, and it's not the way you'd like to see it. So you keep changing it and changing it and changing it, and then it never gets completed. So sometimes you just have to say, okay, this is done. The next time I do it, it'll be better, but right now, this is done. It's completed. I finished it. I'm moving on. And then wouldn't we like to see a future where we talk about leaders? Not necessarily female leaders, male leaders, but just leaders. They'll just be leaders. Careers, and this is applicable to me too. Careers are like jungle gyms. It's not a ladder. It's not like every move that you make in whatever career you choose to do. It's not that you're always rising. Sometimes you make these lateral moves. Sometimes you make the moves that may not be perceived as lateral. They may be perceived as less than lateral, but it's not a failure. It's something that you have to do in order to grow. We have to keep going. I like this quote too, and it's kind of long, but mentors. People talk about having mentors. Is it a good thing? Is it a bad thing? Is it a hard thing? Cheryl says that she doesn't agree with mentors. She thinks mentors are kind of like crutches and allowing people to be dependent on someone else. And if you don't find one, then you are not going to be successful. I don't necessarily agree with that. I think mentors are helpful, but mentors are so hard to find. People talk about a mentor is somebody who you have to develop a relationship with. And it's hard to find someone that you trust enough, that you are familiar with enough, that you will tell them what you're thinking, they feel comfortable enough with you, that they will advise you in a way that is significant. So it's hard to find that mentoring relationship. But in my opinion, mentors are needed, mentors are useful, and once you get one, once you find one, you want to keep one. But I think what Cheryl is saying here is that if you don't have a mentor, it's not the end of the world. You're not doomed to failure. You still have to keep trying on your own. Balance. It's a question of balance. And what I'm finding, what I continue to find, is that there's work, there's family, there's things that you like to do outside of family, outside of school, work, family, extracurricular activities, and there's a balance out there for everyone. And the balance for me might not be the same as the balance for you, but there is a balance. I might like to spend 60 hours a week at work and do little extracurricular activities. Somebody else might say that I can get accomplished the same amount of work, but I don't have to spend those 60 hours. I can spend 40, I can spend 30, but I get the same amount of material accomplished, and I have more time for family. That's what works for me, that's what works for you. You have to find that balance. And what we do is compare ourselves with others and say, well, because John Smith is over there working 60 hours, I must be working 60 hours in order to be successful. May not be what's working for you. You have to find the balance. That's the advice I have. And then we always have the expression of having it all. You know, I've got my work, I've got this nice family over the side, I've got time to go skiing and sailing and snowboarding, and I got a lot of money, and life is wonderful. In my opinion, you can have it all. But for me, my expression is you can have it all, but you can't have it at the same time. You might be able to have this wonderful job that you're working hard at, and then 10 years, you've got this wonderful family that you're working hard at, and then 10 years, you've got these extracurricular activities that you're working hard at. But to do it all at the same time, for me, would run a person crazy. So my advice is you can have it all, but you have to concentrate on what you're doing at that particular moment, at that particular time in your life. What we're trying to do in City College is to talk about how do we make sure that we are engaging our new faculty, our new hires, and our people that we bring to City College in general, so that we don't have what we call isolationism. That will, in my opinion, be a death sentence. You want to make sure that whatever you're doing, you're not doing in isolation. Because it used to be in the 80s that you could be successful by working by yourself, what I call these island researchers. If you're in industry, if you're in academia, government, you generally have to be part of a team. You generally can't do the work by yourself. You have to find someone else that you can bounce ideas off of, that you work together and work toward a goal. Nowadays, research is such that you can't necessarily be that superstar on your own like there were 30 years ago. Partnership and these mentors, not only in chemical engineering, you can find mentors and partners that might be in other universities. You can find mentors and partners at other departments. You can find mentors and partners across the nation, potentially even across the globe. My point is you just have to, you cannot isolate yourself, no matter what. No matter what. You've got a team, you've got to find somebody to talk to, someone to bounce ideas off of, and someone to grow with. I'm going to stop there and say thank you for inviting me. Thank you for coming and doing this. I think it's a great exercise. I think it's a great activity to increase the collaboration here in terms of Michigan, and also expose others to what you're doing. I think it's a great symposium. So thank you.
What makes that liquid so cool? When Professor Jin-Sang Kim and his team first made the new molecule, they found that it could be either a liquid or a solid crystal at room temperature.
Initially, we designed this molecule as a building block for